Okay, welcome back. I want to talk about moving heat around in the atmosphere. This could be transferring cold air down from the north, making the area around your neighborhood colder and increasing heat loss from buildings. This could be heat transferred from the sun that is making the ground warm up and making the buildings warm up and air conditioning running. This could be any number of different factors about the rates at which sunlight is hitting your solar panels or whatever. This is an important block of material, and it can be a little bit, it can have a lot of vocabulary and so on, so make sure if you have any questions, you always feel free to contact me. Now, an introduction to meteorology textbook will always tell you that there's going to be a number of different ways that you can move heat in the atmosphere, and textbooks tend to break it up into conduction, which we've talked about already a little bit, and we'll talk a little bit more about, consider that's an important way to lose heat like through the walls of a building. Convection and advection are about ways of moving heat by moving a fluid. Well, air is a fluid, it flows, so that's an important way to transfer heat. We'll see how, like, a cold north wind is an example of advection, and plumes of rising air at the surface rising up into the atmosphere are convection, and so on. And then we'll talk about radiation. And radiation, of course, has very direct applications as far as moving energy in the context of Energy 301, electrical load and yield, because that's going to be a large part about like how we're going to decide about what is the amount of energy available to solar panels and so on. So let's kind of break these down a little bit here. Conduction. Conduction, as we've mentioned in the temperature lecture, is about moving heat between two objects that are touching but at different temperatures. And of course, the stereotypical example of this is like, cooking. Okay, the food is not at the same temperature as the pan, so heat conducts from the pan into the temperature. Heat only can move from the hotter objects to the cooler objects by conduction. As it happens, air is terrible at conduction. Air is in fact one of our best insulators. This is why we use air as a type of insulation. I mean, the insulation that we put into roofs of building or into the walls of a structure are typically mostly just little trapped pockets of air. Because as heat tries to conduct through those walls, it'll try to conduct through these little trapped pockets of air, or through the trapped pockets of air in your warm fuzzy sweater, or the trapped pockets of air in an animal's fur. It will only conduct away very slowly. And so as a consequence, insulation, like air, is a good way to reduce the rate at which heat conducts away from an object. In the context of meteorology, meteorologists often kind of forget about conduction, because conduction isn't a big factor in like day-to-day meteorology. It isn't like, oh, here's a cold air mass and here's a warm air mass, and where they're touching, heat is conducting from the warm air mass to the cold air mass. Air is terrible at conduction. Really, the only place in the atmosphere where conduction is important is at the surface. There is conduction of heat from the ground into the atmosphere at their interface, where they're touching each other. Typically, like during the day, the ground is relatively cool, the ground is warmer than the air, and so heat is conducting from the ground into the air during the day. At night, it's often the other way around. The ground has cooled, the air is relatively warm, and heat conducts from the air into the ground. But conduction is really only important meteorologically at the surface. Conduction can be important from an electrical load and yield perspective, like in the walls of buildings, the roofs of buildings, whatever. Convection. Convection is another way to move heat. Convection is moving heat. Strictly speaking, it's moving heat by moving a fluid vertically. So like if a warm volume of air near the surface decides to rise, that's convection. Or if a cool blob of air, I'm going to resist using the words air parcel. Meteorologists like to describe these blobs of air as air parcels. If a cool blob of air were to sink, that is convection. We're moving heat by moving a fluid vertically. Strictly speaking, it's advection when we're moving the fluid horizontally. So like warm air from the south coming up to us, that's warm air advection. Or cold air from the north coming over us, that's cold air advection. It's another type of way of transferring heat. And the atmosphere is really good at this. I mean, it's just air. It's not really all that hard to move. So if you have some warm air over, say, the Gulf of Mexico, and you transport it poleward over the central United States, you've moved an enormous amount of energy. I mean, the air holds heat, and you have moved it fairly easily to a different place. From the point of view of meteorology, advection and convection are hugely important processes. Now, from a point of view of energy type classes, we're going to be more interested in the radiation. Of course, radiation is just the transfer of energy in the form of waves in the electromagnetic field. Strictly speaking, radiation needs to be between objects that aren't touching. That tends to not be really a factor we worry about very much. And so the rest of this this lecture is going to be mostly about radiation, because this is going to be the factor that is in some ways the hardest to envision. But before we move forward, I want to ask you a quick question. Let's just, so that we kind of break this lecture up a little bit. Let's say that one day in November, a cold air mass from Canada moves over the United States. And let's say at that time the Great Lakes are relatively warm, they haven't frozen yet. When this cold air touches the relatively warm water of the lakes, heat is going to move from the lakes into the air by A, convection, B, advection, C, conduction, or D, radiation. I'm going to be honest, I think more than one of those choices would be strictly speaking correct, but really only one of those is the best choice. So take a look at your choices there, read the question over again, and then answer the question by following one of the 4 links below this video, which will give you some feedback as to whether you're right or not, and then continue on to part 2 of this lecture.